From the ashes of the Mars Polar Lander, which crashed on Mars, came the Phoenix Mars Lander, headed by Principal Investigator Peter Smith.
I got a call from some of my colleagues at Ames Research, and they said, you know, we could actually do a mission ourselves, and we could use all the elements of the Mars Polar Lander that had crashed in 1999. But the instruments and the people that build them were still, the engineering was still fresh, and it wouldn't be hard to recreate them. And so we started to do that, and they claimed I should be the PI, so I was quite honored. And off we went, and a year and a half later, we had a mission. It was an attempt to follow up on a discovery made by Odyssey. And the idea was that Odyssey had seen ice in the northern polar plains, sort of like we have permafrost in northern Alaska. You couldn't see it with visible cameras, but with their gamma ray spectrometer, they could actually penetrate the surface and see that ice was underneath. And so our vision was to land on that permafrost terrain in the Mars northern Arctic and to dig down to the ice and to look at that ice-soil boundary as a potential habitat for life on Mars. And we designed the experiments around understanding the interaction of the ice and the soil and the chemistry and the minerals that might have formed due to the action of water, looking to see if the ice had ever actually melted over the history of its existence, which might be millions of years. We have discovered some very interesting things about the chemistry of this soil. One is that it has a chemical called perchlorate. Now, most people don't know what that is, and I didn't either when we found it, but it has very interesting properties. If you have a concentration of perchlorate, it'll actually lower the freezing point of water ice down to below the temperature, the normal temperature on Mars. So you could actually have liquid brines made with perchlorate. And that is a potential habitat. So this was very interesting to us. The other thing it's used for, and this was a complete surprise, is it's the oxidant in the solid fuel rockets that it actually launched us into space. And therefore, it's a resource for future missions. Unfortunately, for human missions, it's also a toxin, and you have to be careful at high concentrations, which this is. 0.5% of the soil was perchlorate. Then you have to worry about the toxicity of this material. We found out through some experiments with a colleague down in Mexico City that the perchlorate has the property of defeating instruments that are looking for organic material. And therefore the Viking missions, which claimed there was no organics on the surface of Mars in 1976, and they had done very careful measurements, if they had had perchlorate inside of their instrument, they would have seen nothing, even if there were lots of organics there. And so this is potentially changing our entire view of the possibilities for life on Mars. And now, of course, we have the Curiosity rover, and next week they're releasing some very interesting results from a similar instrument. So I am really curious if they're going to find these organics we've been looking for all these years. We had a very dedicated weather experiment where we could look at polar weather, which had never been studied from the surface. And we have 5 months of detailed records of all the wind direction, the pressure changes, the temperature, the humidity, and the cloud cover. And as we were monitoring this, we were surprised to find it was snowing one day. So that had never been seen from the surface of Mars. People have claimed they'd seen it from space, but not actually being snowed on like we were. And so that was a nice discovery. And of course, we did find the ice we were looking for, and we found a mineral in the soil called calcium carbonate, which is limestone, which only forms with the action of liquid water. So we thought maybe some of this ice might have melted. There's not a lot, but it just, droplets could have formed this over time.